Our continued existence on Earth as a species is not a given. There are many perils we as a society will face in the coming decades. If we allow our technological progress to be reversed by those who fear new knowledge, we will be unprepared to face those perils. All of the resources needed for real change in our world, money, popular support, grassroots advocacy, media access, and political will, are currently controlled by those who view a scientific approach to the world as something they don't need. We are living in a society that tolerates but not respects logic and reason.
Why science appears to be under such attack? It's not just a clash of ideas, but whether people actually trust science. And trust in other scientific theories has also been eroded, such as the safety of vaccines, or that HIV causes AIDS. There have been angry protests against the use of genetically modified foods.
It's time for us to say, no, we don't want it. We don't want that new technology.
Are the public right not to trust science? Or is there something else that's not working?
When we're growing up, we tend to be pretty credulous. We just believe almost anything that people tell us, especially authorities and adults and textbooks and politicians and television, YouTube, the internet. I mean, there's just this sort of sea of information coming at us. And how can you tell the difference between, it's right or it's wrong? How do you know? People believe weird things because our brains are wired up to find meaningful patterns. You think if you see the face in the cloud or the face on Mars or the Virgin Mary in a grilled cheese sandwich or on the side of a window, many patterns are real, and it's good to know what those patterns are, and that's called learning. We connect A to B, and often A really is connected to B. The problem is a lot of patterns are false. They're superstitious thinking. They aren't real. Well, I'm often asked when I give talks, why should we believe you skeptics? And my answer is, you shouldn't. You shouldn't believe anybody based on authority or whatever position they might have. You should check it out yourself. And we call this generally our baloney detection kit, sort of inspired by Carl Sagan's idea that there's a lot of baloney out there and we need a kit to detect it. And that kit is called science, and that's what science does best.
I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we well, don't laugh, that's really true. Then we compute the consequences of the guess to see if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature, or we say compare to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. In that simple statement is the key to science. It doesn't make a difference how beautiful your guess is, it doesn't make a difference how smart you are who made the guess, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it. Now you see, of course, that with this method we can disprove any definite theory. If you have a definite theory, a real guess from which you can really compute consequences which could be compared to experiment, then in principle we can get rid of any theory. We can always prove any definite theory wrong. Notice, however, we never prove it right. Suppose that you invent a good guess, calculate the consequences, and discover that every consequence that you calculate agrees with experiment. The theory is then right? No, it is simply not proved wrong. Because in the future, there could be a wider range of experiments, you can compute a wider range of consequences, and you may discover then that the thing is wrong. The theory had been failed to be proved wrong and could be taken to be temporarily right, but it can never be proved right because tomorrow's experiment may succeed in proving what you thought was right wrong.
Asimov was a great writer of fiction and non-fiction, science and science fiction. He received a letter from a non-scientist who wanted to correct his attitude about science. I'll quote him. "Every century, people have thought they understood the universe at last, and in every century they were proved to be wrong. It follows that the one thing we can say about our modern knowledge is that it is wrong." My answer to him was, "John, when people thought the earth was flat, they were wrong. When people thought the earth was spherical, they were wrong. But if you think that thinking the Earth is spherical is just as wrong as thinking the Earth is flat, then your view is wronger than both of them put together. The basic trouble, you see, is that people think that right and wrong are absolute, that everything that isn't perfectly and completely right is totally and equally wrong. Once people believed the Earth was flat, and they were wrong, but they were also very nearly right. The curvature of a flat surface is 0, and the curvature of the Earth's surface is very nearly 0, to a certain level of approximation, the kind of measurements the ancients were capable of. After some rather brilliant observation by great scientists such as Aristotle, the basic idea of a spherical Earth was advanced and measured a century later by the Greek philosopher Eratosthenes by noting the difference in shadow lengths at different latitudes. We thought then that the Earth was a sphere, and that the actual curvature of the Earth must be 0.000126 per mile, a quantity very close to, but not quite equal to 0. This difference was important in our ability to make accurate maps and sail great distances without missing our destination. So then we thought the Earth was a sphere, but that was also wrong. Based on observations of the other planets, Newton showed that rotating masses are very slightly flattened at the poles. Scientists measuring the Earth very precisely using newer instruments were able to determine the degree of oblateness, the measure of departure from a true sphere. The correction in going from spherical to oblate spheroidal is much smaller than going from flat to spherical. Therefore, although the notion of the Earth as a sphere is wrong, strictly speaking, it is not as wrong as the notion that the Earth is flat. What actually happens is that once scientists get hold of a good concept, they gradually refine and extend it with greater and greater subtlety as their instruments of measurement improve. Theories are not so much wrong as incomplete.
When I think of science, I think of a truly human activity, something that drives curiosity. The goal here is not to make everybody a scientist. That's not the goal. What a boring world that would be. You want artists, you want musicians, you want novelists, poets. You want the rest of this. What matters is whether they're scientifically literate and maintain that literacy and that curiosity throughout their lives, no matter what becomes their profession. Most important feature is the analysis of information that comes your way. How to interpret information that comes to you. How to think about what somebody says. How to judge what it is that someone else says. Judge the likelihood of it being correct or not. No longer can you invoke common sense to judge whether or not that's accurate, whether or not it's true. Because all that matters is that it's measured to be true. Period.
One of the most vocal arguments currently raging is about climate science. Many people seem unconvinced that we're warming our planet through the emission of greenhouse gases.
Are you saying the whole community or a majority of the community of climate scientists are skewing their data? Is that what you're claiming?
Scientists have been manipulating evidence.
Evidence is unequivocal. There's no doubt about it.
It's a subject that polarizes opinion. Not surprisingly, since climate science affects so many elements of our lives, from politics to economics to how we live. With so much at stake, scientists are rightly held to account. What worries me is not just that scientists feel under attack, but that many people think these attacks may be intellectually justified. Searches on the internet do not differentiate between thoroughly researched evidence and unsourced, uncorroborated assertion. Conspiracy theories compete on level terms with peer-reviewed science. Peer review is very important to make science credible. The authority science can claim comes from evidence and experiment, and an attitude of mind that seeks to test its theories to destruction.
We measure scientific progress in our ability to reduce the uncertainties, and by that measure we're making extraordinary progress.
But there may be a problem in the way those uncertainties are communicated to the public. Scientists may not be willing enough to publicly discuss the uncertainties in their science, or to fully engage with those that disagree with them, and this has helped polarize the debate.
Things are a little different when you have a denialist or an extreme skeptic. They're convinced that they know what's going on, and they only look for data that supports that position, and they're not really engaging in the scientific process.
I think some extreme skeptics decide what to think first and then cherry-pick the data to support their case. We scientists have to acknowledge we now operate in a world where point of view, not peer review, holds sway. In this new world of information overload, we look to people we trust to find those answers. And these days, it's not necessarily the scientists. Scientists have forgotten that we don't operate in an isolated bubble. We cannot take the public for granted. We have to talk to them. We have to communicate the issues. We have to earn their trust if science really is going to benefit society. Earning trust requires more than just focusing on the science. We have to communicate it effectively too.
An important task is preparing the next generation for the task of understanding the world in a logical, rational way.
How do you look at the world? What does the world look like through your lens? If you're scientifically literate, the world looks very different to you. It's not just a lot of mysterious things happening. There's a lot we understand out there. And that understanding empowers you to first not be taken advantage of by others who do understand it. And second, there are issues that confront society that have science as their foundation. That influences your health, your safety, how you're going to have to vote, what issues are before you politically. If you're not scientifically literate, it's in a way you are disenfranchising yourself from the democratic process, and you don't even know it.